Okay guys, today we're going to talk about change a base, and it is a quick and easy thing. It's something you can use on the ACT, it's something you can use on any test, and it's one of those nice little logarithm rules to know. And what it happens is if you have like log base 6 of 9. We don't know that. We don't know 6 to the x equals 9. We know that it's probably between 1 and 2, right? Because 6 to the first is 6. It's probably close to 1, but we don't actually know that number. So the way that we can do that is we can approximate that number and evaluate this. So we're going to evaluate log base 6 of 9 by using change a base. And what you can do, and the reason that it works so nicely, is you're going to need your calculator. The log base 6 of 9 is the log of 9 divided by the log of 6. Now notice how I wrote these. This is the common log. So the common log of 9 divided by the common log of 6. And you punch that in your calculator. So I'm going to put that in my calculator right now, and I have the log of 9 divided by the log of 6, and I get 1.226. And that's it. Now, you'll see when I do these, a lot of times instead of using the common log, I use natural log. So I might put in the natural log of 9 divided by the natural log of 6. And I want you to try that in your calculator also, just to show you that as long as you use either the natural log or the common log, you get the same answer, 1.226, no matter which way. And the reason you get the same answer is because you're using the same base. Like here your base is 10, here your base is E. In calc, if you take calc, we use natural log more than common log, so that's why I use natural log a little bit more. So let's just try another one. It's very, very easy. Log base 12 of 22. So to find that, you can make that the log of 22 divided by the log of 12. Or you could write that as the natural log of 22 divided by the natural log of 12. And then you get out your calculator and you put those in. And I'm putting them in right now as I'm doing this, so we can have an answer. I get 1.244 if I round to the nearest thousandth. And you get that same answer for either way. Now you only have to do one way, but it just depends which way you want to do that. That works no matter what. You could have a fraction here, log base 1/2 of 7. It still works. It's the log of 7 divided by the log of 1/2. So you get the log of 7 divided by the log of 0.5, and I get negative 2.807. That one becomes a negative because of the 1/2. Anytime you're taking the log or the natural log of a fraction less than 1, you're going to have a negative. So that one's negative because of this 1/2 power. There is one time that this won't work. Like here, if I have log base negative 2 of 6, if I do that, that means I have the log of 6 over the log of negative 2, which when we were graphing, some of you figured this out already, log cannot be negative 2. So if you try putting that in your calculator, it says error in your calculator, so I would call that a no solution. So that's really the only time it doesn't work, is because you cannot have the log of a negative number ever. There's never a log of a negative number because it's not in its domain. So that's it. Change a base. Quick and easy, something you should remember. You can use it on any standardized test if there's logs on there.